Hello, my name is Jonathan Sunday. I'm Strato's Chief Engineer for Draft Systems, and we're here today to talk about the mechanical benefits of Strato's Selective Cushioning Unit. The Selective Cushioning Unit was designed to provide a more durable and adaptable replacement for hydraulic cushioning units to reduce hose separations and knuckle failures. By studying these symptoms, we've been trying to address and manage the broader root causes at play here. You can see in the cutaway view that the unit is made of a stack of elastomeric pads protected by a flexible housing of steel plates. These plates provide lateral guidance for the pad stack and protection of the individual pads from overcompression in an impact situation. As a single draft pad sits with no compressive force, it rests at what we call its free height. As the pad is compressed, it will reach a maximum compression height and force. When the force is reduced, the pad will naturally return back to its free height at a lower force level. This lower force is by design as a result of some amount of energy being dissipated by the pad material itself. This pattern is repeated during the many compression cycles that a pad will endure over its life in what is called a hysteresis loop. When these pads are installed inside Strato's Selective Cushioning Unit, they're held at an intermediate height by the structure of the unit itself with 30,000 to 40,000 pounds preload. The same principles still apply to the compression and release forces, producing a unique service hysteresis loop. The larger pads in the rear buff pack give the same performance as the draft pads inside the yoke, just more of it. As with the draft pads, the buff pads are held at an intermediate height by the structure of the unit itself with 30,000 to 40,000 pounds preload. Due to their larger size and stroke, each buff pad can dissipate a large amount of energy. As the selective cushioning unit sits at rest in the car, its internal preload prevents over 80% of component wear developed over the road. The unit itself is composed of two individual assemblies. The draft pack inside the yoke operates in both buff and draft, providing up to 3 1/4 inches of draft protection for the knuckle. The buff pack in the rear works alongside the draft pack in the buff direction up until the draft pack is forced solid. The buff pack is only fully activated in larger buff events such as yard impacts, providing a much longer service life for the rear unit. As the unit is compressed in either direction, the pads provide an increasing amount of force, giving the appropriate amount of cushion for the situation at hand. The solid state design accomplishes this without any mechanical components moving under load like a draft gear, and without any hydraulic fluid like a conventional end-of-car cushioning unit or EOCC. Selective Cushioning Unit is designed for easier retrofit into existing car geometry, utilizing the existing lugs in the car. The buff pack can be made shorter or longer for easier retrofit application, where an EOC 9 retrofit would give 7 inches of total buff travel. An EOC 10 retrofit gives 9 1/2 inches of buff protection. The smooth force application of a solid state design provides the energy capacity of 2 draft gears in draft, and 6 to 8 draft gears worth of energy in the buff direction, all while maintaining the existing pocket length already in the car. Back in the assembly layout view, we'll take a closer look at the steel plates that provide the functional support to the pad stack. These plates are sized to match the different pad capacities, but perform similar functions. We will focus discussion on the smaller draft plate, though the individual features apply to the stack as a whole. Each plate has some form of engagement to locate and support the individual pads, and a raised rib around the perimeter as a solid stop for overtravel protection. Each individual pad in the stack gets this same support and protection. As forces increase and the pads are compressed, the central recess of each plate creates a protected internal cavity for the individual pads to extend their service life. While the pads are guided by the geometry of each plate, the plates have two forms of guidance themselves. Each plate is shaped to substantially fill the cross-section of the sill, which serves as a limit for any misalignment. The plates also have interlocking features in each corner. Along with the rigid solid stops, these features actually improve the stability of the stack as it is compressed. For the draft pack inside the yoke, these pads and plates add up to about 525 pounds. For the buff pack in the rear, a shorter EOC 9 retrofit gives you about 375 pounds. This is on par with the hydraulic unit and yoke that would have otherwise been in the car. Both packs are shipped pre-shortened for easier installation. The buff pack spacers can be seen here under the rear nut, which fall away under normal in-train forces. Remember that the selective cushioning unit does have AAR conditional approval for open interchange service, with our oldest units in the field for over 2 years right now as we actively expand our install base on new and retrofit applications. As I said at the beginning, my name is Jonathan Sunday, and I'm Strato's Chief Engineer for Draft Systems. Feel free to contact myself or your local Strato sales manager for more information on this project or any of Strato's other solution-oriented product lines. Thank you.